The majority of Module 6 material is going to be about adding to our existing properties for finding the derivatives of different types of functions. So we already have the power rule, constant function rule, some simple properties. So now we want to start adding to that array of properties. First thing we want to talk about is differentiating exponential functions and log functions. So an exponential function a to the x, or some log function with a log base b. So to start off, let's review the relationship between exponentials and log functions. So exponential and log functions are inverse operations of each other. So similar to how squaring something and then taking its square root, those are inverse operations. If you take 2, square it, you get 4. Take the square root of that, you get back to 2. So inverse operations are any operations or functions that if we apply one and then the other, we just end up where we started again. So for exponentials and log functions, if we have some expression, y equals b to the x power, so some exponential function, then the log base b, so for an exponential function, the base is always this number that's being raised to some power. For a log function, we always have log sub some number. So a log base b of some number y is equal to x. So to move back and forth between exponentials and log functions, those different pieces of the equation just get moved around. And again, these are inverse operations of each other. So that's the relationship between exponential and log functions. We also want to look at the difference between exponential and power functions. So a key as we move forward to taking the derivative of different types of functions is going to be to distinguish between these two types of functions, because at first glance they can look similar, but they are different types of functions and they're going to have different properties that apply, particularly when we're finding derivatives. So an exponential function is always going to be some constant number, a, so that could be 2, 7, something like that, and then it's going to be raised to some variable exponent. For a power function, we start off with some variable and then raise that to a constant power. So this would be like x squared, x cubed. So a power function, the base of that function is the variable. For an exponential, the variable is in the exponent. So wherever that variable is in the base or in the exponent determines whether we have a power function or an exponential function. So to differentiate an exponential function, a to the x, we can say the derivative with respect to x of a to the x is going to equal a to the x, so that function just completely unchanged, times the natural log of the base, and then times the derivative of x, so times the derivative of whatever that exponent is. And keep in mind we already established the derivative of x is always just going to be 1. So essentially this derivative is a to the x, so that original function, times the natural log of whatever that base is. To differentiate a log function with base b, we take the derivative with respect to x of log base b of x. This is going to equal 1 over x, so whatever this value is here, so 1 over x, times the natural log of the base, so all of that in the denominator of that fraction, times the derivative of x. Again, times the derivative of whatever it is we're taking the log of, which again is always going to be equal to 1.